Hi everyone. Today we are going to learn about a fundamental graph traversal technique called breadth first search or BFS. Now BFS is widely used in computer science, especially in problems involving shortest paths, connectivity and even artificial intelligence. So what the agenda for today's learning is, we are going to understand what BFS is, walk through the example step by step and writing the algorithm in code. So let's get started. Now what is BFS? Imagine a map of cities connected by roads. BFS helps us explore this map starting from one city and systematically visiting every other city reachable from it. BFS is level order traversal. It's very important to keep this in mind. So what is level order traversal? It is a sort of algorithm which explores all the neighbors of a node first and then moves on to the neighbors of those neighbors. So for example, if I have a node say 1, if I have 2, 3 and 4, and again 2 has some neighbors say 5 and 6, similarly 3 has 7 and similarly 4 has 8. The level order traversal or BFS would mean that first we visit 1, then we visit 2 and now we will visit 3 and 4, because 3, 2, 3, 4 are on one level and 1 is on another level and 5, 6, 6, 7 are on a different level. So this would be 5, 6, 7 and 8. So now that we understand what is level order traversal, we can think of it as waves spreading out from a starting point. Now what are the key characteristics of BFS? Now BFS uses a queue, which is very important. It is a first in, first out data structure. It explores nodes in layers or levels. Well, as we have shown earlier, BFS explores the nodes in layers or levels. So this can be layer 1, this can be layer 2 and this can be layer 3. So in order to understand BFS, let's create a graph first. This is 1, this is 2 and this is 3. Again this is 4, again this is 5 and 5 has 6. This is an undirected graph. What do you mean by an undirected graph? A graph where the direction is not mentioned. Now let us understand the BFS algorithm. For understanding the BFS algorithm, we need to figure out what should be our source or our start. In this case, we are using the one node to be our source. Okay. Now we declare a queue and also we declare a visited array. Now the visited array would be 1, 2, 3, 4, 5, 6. Okay. Now this visited array, we will initialize all the memory in the array to be 0. This indicates that none of the nodes have been visited, and when we want to visit a node, we will simply put 1 instead of 0. Okay. So what do? We will put this node, one node into the queue, and we will say that the first node has been visited. Now, we will see that when we have the one node, we will see that what are the other nodes which are connected to the first node or one node. Okay. So, here we will pop this out from the queue, and we have two other nodes, which is 2 and 4, right. So, now when we have popped it out 2 and 4, we will check whether 2 is visited or not. 2 has not been visited, and therefore, we can put it inside the queue. But once we put this in the queue, we will say that 2 has been visited. Okay. After that, we will also have 4 here, right. Now, 4 we have to check whether 4 has been visited or not. We see that 4 has not been visited. So, 4 can also be put into the queue. But once 4 is put into the queue, we have to visit 4. So, we have to say that in the visited array 4 is 1. Okay. Now, once that is done, we have two elements inside the queue. We will pop the first element because 2 had been inserted before 4. So, we will pop the first element, which is 2. Now, we have to check what are the nodes which are connected directly to 2. So, what have been connected to 2? We have 1, we have 5 and we have 3. But before inserting 1 into the queue, we will see that 1 has already been visited. So, we will not consider it. Now, we have the 5 node. The 5 node we insert because 5 has not been visited. So, we will visit 5 and this has already been inserted. Now, we have another the 3 node. 3 node we see that it has not been visited. So, it is 1 and we have 3, right. So, once that happens, we have 3, 4, 5. Okay. Now, what do? We will pop 4 because 4 has been inserted before 5 and 3 and Q is a first in first out data structure. So, 4. Now, just see what are the elements to which, what are the nodes to which 4 has been is connected. 1, we see that 1 is there, but 1 has already been visited. So, we will not consider 1. Okay. The next element which we will consider is 5. Now, 5 we see is connected to 2 and also 6. We see that for 2 we will not do anything because 2 has already been visited, right. So, what do? We will see 6. 6 has not been visited yet. So, we will say we will put 1 here and we will insert 6. Okay. The next element which we have is 3. Okay. We will pop this out and 3 is connected to 2, but we see that 2 has already been visited. So, we will not do anything with 2. The next element that we have is 6. 6 is connected to 5, but what we see here is that 5 is already visited. What we can see here is that the BFS traversal has been done because we have visited all the nodes. We see that all the nodes have been visited. Now, if you want to see what is the order of the BFS traversal, is this, since 1 is the source node, then from 1 we go to 2, then from 2 we go to 4, then from 4 after that we go to 5 and after that we go to 3 and then we go to 6. So, this is the BFS traversal.